I'm starting with today's session. So it seems that people are started joining. Section DEF, Programming for Problem Solving Theory. Yes, everyone, please write your roll number and respective section along with it. Okay, so students have started joining. Hello everyone, and good afternoon to you. Is my voice audible and the picture is clear? Please respond with a yes so that I will be able to know whether it's working fine. Okay, so it's fine. The voice and the picture quality, everything is fine, right? Okay, thank you. Okay, now let's start with today's session. So I'll just brief you what needs to be done about this very theory and lab session that we are having. So the theory session is happening in a joint form and the lab is happening in an individual format that we had previously. In this very theory, what we will be having is we will be having a 20-25 minutes at most lecture format, and within that very lecture live streaming we will be talking about the various topics of programming for problem solving, and a particular assignment is given will be given actually to your respective Google classrooms. So what you will be doing is, after this very session gets over, so you will be going there and you will be solving those assignments and you will be submitting those assignments in your Google Classroom itself. Your assignment will be marked and will be checked by all the faculties of the in the Department of Computer. So the teachers will check your assignments and will return it back to you and will highlight the comments and everything which needs to be modified, and everything will be mentioned in your assignment itself. So this is the format that we are going for, and hopefully it will be successful. Please do tell if any sort of changes and anything needs to be done, because this is the first time that all the faculties are doing, and your cooperation is very much important. So if you do not tell what needs to be modified, what needs to be done, sir, do this, do that, it's very important, because we need to change ourselves, so that we need to make this very class interesting. I don't want a boring class, and nobody does want a boring class. So it's better that if you tell what needs to be modified, what needs to be changed, we can modify accordingly, right? So we will proceed with today's class. Let me just check that how many people have joined for now. Okay, so till now it's 48. I suggest that you tell your classmates section D, section E, section F. Please share the link, because I want the class to be at the very same time. I want everyone to be here at the very same time. So it will be helpful, it will be interactive. I am not just communicating with you, there are the other faculties also there. They will be listening to your problems and everything, and they will be typing over there in the live chat. Okay, now for today's class we will be discussing about the dynamic memory allocation and a little bit of string in C programming. So for dynamic memory allocation, what we have done is we have talked about malloc or memory allocation. Now just could you tell me what is the standard library for this very malloc or any dynamic memory allocation function that we have in C? Yes? So I'll just give you 5 seconds. 1, 2, 3, 4, 5. Okay, no answer for now. Anyway, it's stdlib.h, right? stdlib.h or standard library, right? stdlib.h. This is the standard library that we have for malloc or what we called as malloc. Right? A simple syntax will be something like this. Int star p. Obviously this is within the main function. I'm just writing the code snippet for now and simply writing p is equal to, over here what needs to be mentioned I will tell later on, but let's proceed with malloc, and I am giving size of and providing p, or what you can do is simply write int over here. This malloc size of int, what it will do is it will provide the size of int, that is it can be 2 bytes, it can be 4 bytes, right? Accordingly the amount of memory will be reserved. So what we need to do is we need to call this malloc function and pass the number of bytes to it. The malloc function, what it will do is it will simply perform a system call. A system call is nothing but a request to the operating system kernels. The operating system's kernel is the brain of the operating system, not the heart. It is the brain of the operating system. So all the operation has to happen through the kernel. And what is the language of the kernel? It is system calls. So it is like this. We have the operating system and we have the kernel over here, and we have the shell, which is the user interface. So this is the user interface. Application program, what it does, it makes a request to the operating system kernel that give me this amount of memory, and what the operating system kernel will do, it will give you the memory, right? So this amount of memory of 2 bytes or 4 bytes according to the compiler will be allocated, and say suppose the address is 2000, this 2000 is given or is returned by the malloc function. So this address is returned and gets stored here into p, but p is a integer pointer, and what type of address the malloc returns? It returns a void pointer. Now what is this void pointer? There is a tongue twister. Void pointer is a pointer that can be pointed by any other pointer. What does it mean? It means that this very address can be stored inside p, which is fine, but we cannot access or we cannot dereference it. This is a very big problem. Dereferencing means what is inside this we cannot access it. So in order to store this 2000 address which is returned by malloc, it has to be stored in p, which is happening, but it has to be formatted. So what needs to be done? It has to be typecasted. So we returned, this is a void address or void pointer address. It has to be converted into the integer pointers address, which is int star, which is done by int star. So this is typecasting. And what type of typecasting this is? Explicit typecasting, because we are explicitly mentioning this. If we do not mention anything, automatically if any sort of typecasting happens, then it's called implicit typecast, and this is explicit typecast, right? Now this is the very format of this malloc or malloc we say, right? Now this is for what after this very operation, what happens is we have this p. So p is over here, and p will be holding what? P will be holding 2000, and it will be pointing to this. If I want to store something inside this, what I need to do? Star of p is equal to 5. What is p? P is 2000. The person is standing here. Star of this is inside the box. So if I want to store 5 over here, I just mention this and 5 gets stored over here. Simple as that. Same goes for your array operation also. Let's proceed with an array. Okay. P is equal to int star malloc size of int multiplied by 5, right? Size of int multiplied by 5. So what we want for now is, we want the malloc function to request the kernel that allocate the size of int. Obviously, if it is 2 byte, if it is 4 byte, accordingly. For now, we are considering only 2 byte. So 2 bytes of how many? 2 bytes of 5. 5 blocks each, right? So 5 blocks of size of int, right? Achha, just 1 minute. Okay, fine. 5 blocks of this size of int. Now, so this is being allocated 1, 2, 3, and we have this 1, 2, 3, 4, 5. Now the address is 2000. The next address, if it is 2 byte, 2002, then 2004, then 2006, then 2008. So this is being allocated each of 2 byte, each of size of int. And how many such? 5. And this P is over here, and what it does is, this very address 2000, this base address is returned by malloc. It is being typecasted and it is being stored inside P. So P will be holding 2000 and it will be pointing to this, right? So we have the very same array allocation, array memory allocation, but this memory allocation is happening during the runtime. What we had previously done was for compilation time, which is called static memory allocation. Simply writing P of 5 did the job. But this cannot be changed because it's statically allocated. So now what we are doing is, we are allocating this very memory during runtime. Now after this very operation, we have something like this, right? So now what needs to be done is, if I want to access this location, so P is 2000, right? So person is here, P is 2000, the person is here, start of this is inside the box, so this is equal to 5, simple as that. Or simply writing star of P plus 0 is equal to 5 will also do the job. Again, star of P plus 1 is equal to 6. P is 2000, the person is here, plus 1 is over here, and star of that is enter the box, so 6 over here. So writing this same, or writing P of 1 and writing P of 0, this can also be done. So we can simply access it by star of P plus I or P of I. Because P is 2000, plus 1 is 2002, plus 2 is 2004, plus 3 is 2006, and again star of that is enter the box. Simple as that, what we have done for the class itself. Now let's proceed with the next memory allocation function that we have. So this goes for malloc. I'm just hurrying it up because we have very less bandwidth to spare, right? So I'm just hurrying this up. Now the next memory allocation function that we have is called calc. Int, so I'm just writing the heading for now. Calc int star P, right? P is equal to, obviously we need int star for typecasting, and this calc function is used But with calloc function, what you do is there are two parameters that needs to be sent. Two parameters. Now these two parameters, why? Because one parameter will specify the size of or the amount we want, and the other parameter specifies that how many of that very size we want. So same as what we did for malloc, but a little bit different. Over here we specify the size if it is 5, and then we specify size of int. So size of int, we want 2 bytes. How many such? 5. 2 bytes of 5. Over here, this very 5 can be replaced with a n, right? And after this very operation, we will be having the indexes n minus 1 starting from 0 to n minus 1. And this very address, if it is 2000, this gets stored inside P. And P is pointing to this, right? So we have this very structure after this very calling of calloc function. But one thing to remember, the difference between malloc and calloc is malloc, what it does is over in malloc it is filled up with garbage values, because over there is no such predefining of values. But in calloc, every location is initialized with a 0. All the n elements will be initialized with a 0, right? So this is what happens, and this is what is happening. In malloc we have some garbage value filled up, but in calloc we have zeros predefined. Another difference is over here in calloc we have 2 parameters, but in malloc we have only 1 parameter, right? So this is another way. We will talk about the 2D array allocation or 2D memory allocation, right? We will proceed with that, but not for today. Now for the next memory allocation function we have is, this video will be recorded. After this you will be getting it for after a particular scheduled time. So if you miss out anything, you can look into that, right? Now this is calloc, this is done. Now we have realloc. Realloc, this is a very good function which is used for reallocation. Reallocation means say suppose you have statically defined or you have dynamically defined, or say suppose any sort of memory has been freed, right? So you can realloc that very memory or reallocate that very memory using the realloc function, right? So a simple example will be like this: int arr 2, right? Int star ptr, this can be done, and another is star ptr 1, right? If I write something like this, ptr is equal to arr, what will this do? We have this very memory, and there are 2 such location. First one is 2000, the other one is 2002. This 2000 gets stored over here, it is pointing this, and the name of this is arr. ptr is another pointer which is holding what? It is holding the value of arr. ptr is equal to arr. What is arr? It is 2000. 2000 gets stored over here. ptr is also pointing to this. Simple as that, right? Now we want to reallocate the memory of this very ptr. This can be done, but we will be using another pointer for this very purpose. Let's do it. I'll just show you. I'm showing it over here. Now ptr is pointing to this. Simply if I write this, ptr 1 equal to realloc. Within realloc, the first parameter that I will pass is ptr, and how much size or how much changes do I want is this: size of int multiplied by 5. ptr is equal to realloc. Within this pointer is sent to this, that I want to change this size of the, obviously you can send arr also, this can be done, so no problem with that, but we are changing this. So after this very operation of calling this, we are changing the size to 5 such location of integer. So this will be modified and the changes will be like this: 1 2 3 4 5, 2000, 2002, 2004, 2006, 2008, and we have ptr, ptr1, this is 2000, this is also 2000, size got changed, and this is what realloc does, right? So you are able to see this. So this is, I think this is visible quite. So this is what is happening. This is how you reallocate the memory. So this can be done, and I want to free up the memory. Say suppose I want to free this very ptr pointer. So what you can do is, free is a deallocation function. You deallocate the memory, so it returns back to the pool of memory in the RAM. So from the RAM we had allocated some memory. If I want to free up that memory, I need to use that free function which is in the standard library stdlib.h. So we have talked about what? We have talked about this malloc, we have talked about calloc, we have talked about free, and we have talked about realloc, but free I haven't shown, I'm just showing it to you. So this is what is for this very allocation, and after this something like this happens over here. This memory is being allocated. This is what malloc address returns. This is p, and I want to free up what is here. So I call free and then I type p. After this very operation, this memory will be freed and nothing p will be holding, right? Null or something like that will be there. So we are freeing up the memory, right? So this can be done. Now let me check the chats for now. Just type yes if you have understood whatever has been taught till now. Just type yes so that I can proceed with the string. So it's cleared, everyone? Hopefully everything is cleared for now. This memory allocation, malloc, calloc, realloc and free. Yes, okay, fine. So let's proceed. So string manipulation. Now string manipulation, what we will be doing is, what is a string? Simple as an array. There is no difference. A string is actually a collection or a contiguous block of characters, right? So a character array is actually a string. So simply writing, if I do something like this, int char, sorry, char C5, char C5. So 5 such locations which can hold character. So over here C of 0 is equal to A. C of 1 is equal to E. So A is a character, E is a character, right? So this is there, which is fine. But there is an extra character which is associated with this, and that very extra character is nothing but a null symbol, which is there at the very last of every character. So A, E, like that, if I store some characters over here, it will end with slash of 0. So we have this slash of 0 at the very last of every allocated string, right? This is very important because this indicates the end of string marker, EOS, end of string marker, right? This is very important because this specifies that this is the end of the string, right? So this is how it is. Now, after this very allocation of string, if I want to manipulate it, obviously there is function. Many of you have done Java, many have done Python. So there we have various uses of functions. Over here in C we also have that. But it's better that we are talking about learning data structures out of this. So C++ will provide you the actual environment for learning these data structures, because over here you have to work, alright? So it's better that you do all those string manipulation function using your hand. What are the manipulation functions that we have? String concatenation, joining two strings, string substring, a part of string, string length, are the basic operations. These has to be done using your own intellect, and it has to be done through with the help of loops. Okay, now one thing, the stream is okay, the stream is going on. Someone wrote that the stream froze. Is it fine? Okay. Okay, so I'm proceeding right now. Not this. Let me char star p is equal to something char c. Just one. Now this is one operation that I am doing. Now in this very operation, what is happening is, if I do something like this, what will happen? So let's forget about this line for now. Or let me simplify this, because you are considering an array for now. What will this do? I have simplified it for now. So let's consider this. We have an array, and within that very array, what we have? We have H, we have E, I have L, L, O, and after this I have an end of string marker which is /0. So this is it. The address is 2000 and 2000 is stored over here. So this is how it is kept. Now, while p plus plus whole star, just simply nothing else, while p plus plus whole star, while what it does is it checks whether the very thing is true or not. If this very content, if it is having some value, then it's fine. If it is null, then it will stop. Right? So within while, what we have done is we have written star of p plus plus and this has been closed. And within this printf mod c star of p. So p is what? P is over here. P is 2000. Right? P is standing over here. Now star of p plus plus, plus plus means it's a postfix operation, right? It's a postfix, that means it will not happen here, it will happen sometimes later on. So star of p plus plus, what it will do is p is 2000 and it will perform star of p, which is h. So h is happening, it is not null actually. So what we will do is we will enter the while loop, print mod c star of p. What is star of p? H. H is printed. Now, after this very operation of this printing, p becomes plus plus and p becomes 2000 plus 1, which is actually 2001. So this is now pointing to here. Now, after this, again star of p plus plus, p is 2001. So 2001 star is E, which is not null. Right? So it will enter, it will print mod C star of P. So what is star of P? E. E is being printed. Again, P plus plus. So this increments by 1. So it goes here. And this becomes 2002. Again, star of p plus plus, so this is checked. So whether this very thing has a value or not, star of p plus plus, what happens is 2002's content is L, which is true, and it enters and printf mod c star of p. In this very manner, L O gets printed and this p goes at the very last, which is 2002, 2003, 2004 and finally 2005. What is star of p plus plus? Can anyone tell me? Star of p plus plus is actually null. So this doesn't enter and it comes out. And what gets printed is hello. Right? So every character is traversed. So simple way of writing this is this can be done. P is equal to P plus 1. I had just incorporated the whole thing into one line. So that is a way of writing the whole thing in one line. It's a complex way of writing, but I had shown you. Star of P not equal to 0, not equal to null, then proceed, then increase P by 1. Then check again, proceed and increase P by 1. So this very process is done again and again. Right? So this can be done. Again, another way of accessing is what? Another way of accessing is with the help of I. You use I equal to 0. You simply change this whole of this to P of I not equal to null. Printf, what you print? P of I. And simply increment I is equal to I plus 1. This can also be done. Right? So there are many ways of actually executing this very string. You either use it with pointers or you use it with array indexing like we did for this. Now, after this very operation, let's proceed with the input taking from the user. No, we cannot write y this y instead of star p plus plus. Yeah, star p it can be written obviously star p. That can be that is fine. But what I have shown is it can be done in that manner also. What you can write star p and p is equal to p plus 1. That can also be done, right? Now, char C5 scanf mod of S. Over here we are taking what? We are taking mod of S and we are specifying simply C. Can anyone tell me why did I write simply C, not ampersand C or ampersand C of I or something like that? Because this mod of S is actually specifies a string, and this C is actually the base address of the array. It is actually base. If you closely observe and closely think about it, it is actually this 2000. This is what is C. I am specifying this 2000 over here, right? 2000 is specified over here, and this mod of S will ask the user to enter something. The user enters. Say suppose the user enters hello, HELLO, presses a enter or a white space. This very scanf will stop. So you cannot take a line. You can only take a word, because scanf stops where there is white space. It stops scanning whenever it receives a white space. So this happens in case of scanf. So how to overcome this? If I want to take a line that it has been raining, how will I take this, right? You replace this scanf and you use another function which is called puts, and within puts you specify C. Puts, what it will do is it will take the whole of the sentence. So you can write the whole of the sentence, and if you press enter after that, then it will come out. So a whole line can be taken and it can be stored inside the C, including the spaces. The spaces can also be included. So I can take something like this: hello space, my name is. So everything will be a character, and we will have something like this. So this can be done with the help of, sorry, puts, no, I'm sorry. This is getters. I mentioned wrong, sorry. It's getters. Getters is used to take the string or take the whole of the string from the user, and this very getters, or there is fgetters. Fgetters is another function which can be used. So getters is used for taking the very string including the white spaces and taking the whole of the line into the very this array. Again, if I want to print, this, simply I need to mention printf. Within this mod of S, and I will specify C. Nothing else, only C. Just look at this. Say suppose hello. This is 2000. 2000 is over here. It is pointing to this, right? Printf mod S, and what we have is C. C is what? C is 2000. C is 2000, that means that we are printing from 2000 and we are printing until or unless we receive a /0. So this will start printing from C, this. So this is C. It will start printing from 2000. It will keep on printing every character until it reaches this /0 or this null. Right? So if I do something like this, just modify this with C plus 2. Can anyone tell me what will happen? C plus 2. What will be printed? So C is 2000 over here, plus 2 is 1, 2. From here, from this very index, it will print L, L, O. Because after reaching here, it will come to here, which is /0. So it will print this very L, L, O. And it will stop. So from the very address that is provided here, it will print the string till it reaches the /0 or till the end. Right? This is what printf mod s does. Simply printing a character. Mod of C, C of 1. What will be printed? This is character printing, not string. Mod of C, C of 1. C of 1, this is 0, this is 1, this is 2, 3, 4, 5. 1 is this, E will be printed, right? Simple as that. You can check for character. Say suppose I give you to check if the name starts with A, or if print the vowels that are there in the particular string. So these all things can be done. Character checking whether the vowel is present, parsing throughout the array and printing all those this very vowels. Or if I tell you to print the count of vowels, how many vowels, A is how many times, E is how many times, like that it can also be done. So these are small examples that we can do. I will just stop over here. Now I won't take much of your bandwidth. So you go, there is a theory assignment that is given. So you do the theory assignment, right? And you submit the theory assignment in your Google Classroom. So we will halt for today. Hopefully it was okay. Let's check for any queries. So it was fine, right? Just tell me if it was fine, or if you want to change something, if I need to modulate myself, just tell that accordingly. Okay, yes, Sara data to khatam ho gaya. I know that. I just cannot help. Okay, I will start with OBS Studio from the next day onwards. So it will be helpful. I think a little less data will be there. Okay, thank you everyone. Thank you for coming, right? Bye bye. And go into the Google Classroom and do the assignments and submit the assignments there. And stay safe. Stay at your home, right? Bye.